Alright, I was going over some of the videos and I didn't cover series as much as I feel like I should have. So I'm going to go over that again real quick. It's pretty basic, and we're just going to cover how to add up resistive loads in series. And we can use that for future circuit analysis. I don't really feel like there's reason to spend too much time on it, but you do need to see it so you can properly understand it. So, from our notes, remember resistance is additive, voltage is additive, and current is common. So, let's go ahead and just look at these three resistors and see how we're going to get the total resistance of this. Now, remember, resistance is additive, so all we do is we add those totals. So 1000 plus 2200 plus 3900, and it's easy enough. RT is 7100 ohms or 7.1 k ohms. Okay, pretty simple. But then we can get to something like this, where we have two series resistors and then a set of parallel resistors in series with those. Really, the same rules apply. Resistance is additive in series. So R1, and then you add R2, then you add the total between R3 and R4. Okay, now remember, we have to use our inverse, or the sum of the inverses formula for those. And there's other equations out there. I find for myself that I memorized this formula. It's easy enough to do on a calculator. I don't need other formulas. There's a few out there, especially if you're just using two resistors. So first we want to find the total resistance between these two, and this is the proper notation. So R3 in parallel with R4. So R3 is 3900 and R4 is 5600. And remember, we can also annotate this with kiloohms, so 3.9 kiloohms and 5.6 kiloohms. So to do that math, it's easy. We just do 1 divided by 3900 plus, and we use parentheses, 1 divided by 5600. And then we want to get the inverse of that. So we'll just do 1 divided by 0.000435. Remember, 3 significant digits. So the equivalent resistance between these two is roughly 2298.9 ohms. So we just add that total to the 1000 for R1 and the 2200 for R2. So the total equivalent resistance for all four laid out like this is 5498.9 ohms. Okay, it wouldn't necessarily be wrong to say 5500. Just saying. Now, if we had much more of a circuit going along with this, that 1 ohm or that 1.1 ohm may affect your calculations a lot. So keep that in mind. Now, if I took and I had power going across the circuit, and VT, let's say it was 10 volts. Now we can calculate total current across those four. That meaning the current going out of our DC, the amount of electrons going out, and the amount of electrons going in. That's easy enough. Remember, we have our Ohm's law card. We have voltage divided by resistance. So 10 volts divided by 5498.9. And that's 1.82 milliamps. That means also, because this is just review, we're not going to do detailed analysis, but that means that I have 1.82 milliamps going across that resistor, and also that resistor is the same current, it's the same electrons. They're visiting R2 and then they visit R1 before they hit the plate on the battery. Then a portion of those resistors go through this one, and then the other portion goes through this one, and we can do the math to figure out how much. But I just wanted to go through just the adding portion of this, and I'll make another video on detailed analysis of a circuit like this. In fact, I have it right here, and we'll go over this in detail in another video.